Okay guys, let's look at another example. So by using the first principle, find the first derivative for y equals to 2x squared plus 1. So first principle, of course, we are talking about the changes in y and changes in x. So what are we going to do? So each terms for y and x, we need to add the changes in y and changes in x respectively. So y plus delta y is equals to 2. Okay, this is x squared. Therefore, x plus delta x squared plus 1. So, of course, expand y plus delta y. So, 2 expand. We have x squared plus 2x delta x plus delta x squared plus 1. So, y, substitute y with 2x squared plus 1. So, 2x squared plus 1 plus delta y is equals to 2x squared plus 4x of delta x plus 2 delta x squared plus 1. So, we can see 2x squared and plus 1, we can cancel out. So, our delta y is equals to 4x delta x plus 2 delta x squared. So, what is our delta y delta x? Delta y delta x should be equals to 4x plus 2 delta x. So again, we are talking about the first principle for first derivative. So we want to find dy dx. So dy dx is equals to limit from delta x limit delta x approaching 0 for function delta y delta x, which is for x plus 2 delta x. So here, we can see that we can substitute delta x with 0. So, for x plus 2 times 0. So, we have our dy dx is equals to 4x. Again, when we have dy dx in terms of x, this is called gradient function. But when we talk about gradient tangent, we need to substitute the value of x. So in this question, we don't have the value of x. So this is our final answer by using first principle. Okay, the next example, we have function y equals to 3 over x. So y is equals to 3 over x. And then by using first principle, y must be added with its changes. So do x. Okay, so y is equals to 3 over x. So 3x plus delta x. So delta y is equals to 3 over x plus delta x minus 3 over x. So we have fraction with operation subtraction. So what we will do is find the common denominator. So delta y is equals to 3x minus 3 x plus delta x over x times x plus delta x. So expand, delta y is equals to 3x minus 3x negative positive negative 3 delta x over x plus delta x. So delta y is equals to negative 3 delta x over x plus delta x. So we need to find delta y delta x. So this is delta x, this is delta y. So we can say delta y delta x is equals to negative 3 over x times x plus delta x. So what is our dy dx? dy dx based on first principle is equals to limit delta x approaching 0 for delta y delta x. So dy dx is equals to limit delta x approaching 0 for negative 3 over x times x plus delta x. So apa kita buat apa ni? Substitute delta x with 0. So dy dx is equals to negative 3 over x plus 0. So dy dx is equals to negative 3 over x times x, which gives us dy dx is actually equals to negative 3 over x squared. So our gradient function is negative 3 over x squared. Okay. Before I forget, dy dx can also be written as y prime. So we can say y prime is equals to negative 3 over x squared. So again, I remind you, the purpose of differentiation is to find the gradient of a tangent line at a point on a curve. So this is the gradient function for this function. Okay, see you next class. Thank you.